Well, I don't know if I'm live yet because I get an error that says poor streaming quality. But I think I'm live. Hi, I'm Tim Van Milligan. This is RockSim Live, where we talk about the RockSim software. If you're new here and you're watching live, on the comments, and I have a monitor over here that I'm monitoring, go ahead and say your name and where you're from. We've got a lot of people in the room so far. Wow, we got somebody from India, from Indiana, North Carolina, Marietta, Georgia. Wow, from Mark Sell from Parker, Colorado. Mark has a question, and we're going to get to that question here. Boy, there's a lot of people just popping up all of a sudden here. This is really great. Thank you for coming. I really appreciate you being here. I've been missing you. For the last 2 episodes, I've been away. I have been out of the country. I was in Buzău, Romania, at the World Space Modeling Championships. So you're probably wondering, what was all that about? So I'll show you a couple of little photos. Let me switch to my desktop here. This is on the contest field. This is, they had all these old military tents. It was very old and rustic, but it was a good time. The weather was chilly in the mornings. It was in the upper 40s when we got out in the field. And then most of the time it warmed up to about 60 degrees Fahrenheit. It was only the last day that it was really cold. And then the last day it didn't even get up to 50. And it was windy and cloudy. But fortunately, it was only one day. So that's kind of what that looks like. Let me throw some more photos here. This is the contest field, and in the distance back here, you see this city, and this was kind of a weird place because, out in the middle of nowhere, all of a sudden there's this city. And it's different from the United States because the United States, the cities grow up around like a river or a lake. This was like big city out in the middle of the plains. And it was an old city. So it's like, what? To this day, I still don't understand how this city got started and why it grew so big. But it was very old, and the streets were very narrow, but you could see it from the contest field. We were about like 10 kilometers away from the contest field. This is, these 2 girls right here are my daughters. They were flying. They were in the contest. I was there as a sponsor, as just a spectator, helping them out. And they did pretty well. They had good flights. This is the U.S. team that went over there. It was smaller than normal. It was about 1/3 of the size of a typical U.S. team. And the reason for that, as you would expect, was because of the COVID situation. A lot of the team members didn't want to travel and take that high risk of being stranded over there in case they got COVID. Nobody that I know of that went over there, either from the United States or from any other country, got COVID that I know of. So it was it was a safe event. We were outdoors, and UV light kills the virus, so we weren't too worried when we were on the field. It was only when we were in buildings and enclosed areas. I am like way back here in the back. This was the opening ceremonies. They brought out a military band. And they also had a flyover of military jets. I don't think I got any pictures of that. But the host country, Romania, they actually, they did a pretty good job. Can't complain too much. Let's see, I think I got one video I'll show you. It's a very short video. It's only about, 30 seconds long. Let's see if I can find it real quick here. I think it was this one here. Okay, so this is kind of shows the field, and yeah, you can see it. I don't think you can hear any sound, but this right here is my daughter, and she's going to launch a streamer rocket, and it took off pretty good. So like typical, it's like a model rocket launch anywhere you would see. It just happened to be in Romania, and we were there for 2 weeks. The first week we were actually on vacation, and we were doing southern France along the Mediterranean coast. France was like the only country that was allowing visitors in. Other countries like the Netherlands were, you know, because of COVID, nobody could get in. But we did get into France. And yeah, that was fun. France, it was really nice and warm along there on the Mediterranean. The Mediterranean kind of reminds me of California. Really beautiful weather, lots of little mountains, and a lot of people. But the roads aren't as good as in what's in California. So you got that going for you, California. So I'm really glad to be back. Let me show you. Maybe put this on back to wide angle. I'll show you kind of the rockets that we were flying here. So this is one of the rockets that my daughters were flying. This is a streamer rocket and helicopter and parachute, pretty much all the same size. This rocket, I just weighed it, weighs 4.8 grams, so it is really light. And I was really proud of, you know, when we made these things, me and my daughters, how light they came out. Because in order to, the hardest event is actually streamer duration, because in streamer duration, it's getting as high as you can and having the lightest weight rocket you can, so they come down really, really slow. And the United States did pretty good in this event. The adults, my oldest daughter was on the adult team. They took a silver medal as a team. My daughter didn't win any medals herself, but she did win as a team. Kevin Cusick won the silver medal as an individual, but you know, in order to win a team medal, everybody has to do good. It's just not one person can carry the team. It's the entire team has to do good. So my daughter, she did really well. And then my youngest daughter, she did take a bronze medal in streamer duration in the junior competition. And she got the bronze medal, and they also gave her this trophy. So this is my daughter's trophy. These are actually little souvenirs. This is a pennant. It has the Romanian flag in the background, and they're part of the EU, so they got the EU flag and the Romanian flag. So if anybody's watching from Romania, which I probably doubt there is right now, but it was a good trip. Thank you for hosting us. The next world competition will be held in Austin, Texas in 2023. And if you would like to participate, now is this time to start preparing, because it is a long process. And I'm going to get into more detail on the actual process in my next newsletter, Peak of Flight newsletter, which will be out in 2 weeks from last Tuesday. Because Tuesday was a newsletter, next week will be a video, and then it'll be a newsletter again. So if you're not a subscriber to our newsletter, let me show you how to do that. You go to the Apogee website, and up here in this banner bar, there will be a banner here to sign up for the newsletter. You just click on that, and then you submit your name and your email, and you hit "I'm not a robot," because robots like to subscribe too, but we only want people on here. And then we'll get you on our newsletter list, and then you'll be notified when there's a new newsletter. You'll also get a free book of 25 rocket plans as a PDF. Lots of great rockets in there to build. If you're new to RoxIm, let me show you how to get to RoxIm. You go to How-To and Guides. You just come here to How-To and Guides, come down here to Software, click on Software, and then you come to What is RoxIm. You can see what it's about. There's a free trial you can download, RoxIm 10 free trial, and that gives you 30 days of using the software. And then over here are tutorials, and then there's the video tutorials that you can watch. And then there's also the RoxIm live training, which is what we're doing right now. Those will be archived here under RockSim Live Training, and you can see we are on episode number 40 today because here's episode 39. It gives you a link to watch it, plus gives you all the topics that we talk about and the timestamp on when those topics are talked about in the YouTube video. So that's kind of preliminaries. I am so glad to be back. While I had fun outside the country, there's really no place like home, and with my good friends here watching this video. So I'm looking for questions. So if you have a RockSim question, go ahead and give it to me. Someone, John Doe says, you're live, a little bit of static in the background. Am I still staticky? Let me know. I don't know if there's much I can do about it. I can play with my cord. My microphone says it's broadcasting okay. There is a harsh lag with the video. Audio is good though. I think the lag on the video is a result of we're using a software called Visual Studio. No, OBS, Open Broadcast, something or another. And what it does is allows me to have these cameras out here in front that are different from a camera on my laptop, and that allows me to give you a wide angle, and I can pick up rockets and show you things. And I actually have two cameras running there. I've got a close-up camera and a wide angle camera, and so I got both of those signals coming into my computer at the same time into that OBS software, and then the OBS software processes it and then sends it out to YouTube, and it's also doing a screen capture at the same time. And I think that there's so much information coming in that there's a video lag, and so maybe my voice is not matching up with the video that you're seeing. So I apologize for that. Someday when I get a better, faster computer that can handle all this bandwidth all at once, it might be better. And this is a fairly new computer. It's only a year old. So there's just a lot of information coming in. Joe Doe says, yes, still static. Let me see. Let me start unplugging some things here. I just unplugged my a floppy disk. Got this. I'm playing with my microphone cable right here. Sometimes the connection here can be a little bit flaky. We got our first question from Miko Elijah. He says, how can I add my own rocket motor? And then there's another question from John Doe. Will the launch visualizer monthly fee be the same as RoxIm Pro? I'm leaning towards RoxIm Pro next fall. RoxIm Launch Visualizer, for those of you watching that aren't familiar with it, is a new product that we're still in beta testing on. And you can test it out yourself. And it's the web address roxim.com. If you go to roxim.com, it will load the launch visualizer. It's still loading. It's a pretty big file, and it takes a couple of seconds to load, but once it loads, it's pretty good. So this is what it looks like. It allows you to run launch simulations pretty quick. I'm signing in. My login failed. Let's try it again. Let me open Chrome. I think my Chrome is a little bit better. I'm bringing over Chrome here. Make the screen big enough so you can see it. And roxim.com. Take a sip here while this is going on. Okay. we are still in beta on this, so every time you open it up while we're in this beta period, you got to kind of empty your cache first, because the programmers are still working on it and they're making changes every day, and sometimes those changes, in order to see those changes, you got to empty your cache. Okay, so I am logged in and I can choose a design. I just want to run a quick, I'm just going to run a simulation real quick. So there's, when you first start, everything should be loaded. And then you can just click down here, which is underneath my picture. Here's the launch button right down here. When you click on it, it will launch the rocket. Okay, so it's hit simulate, and it takes a second to run the simulation because it's running it in the cloud on our server. So all the data is generated there, and then it passes it back to your computer so you can actually see the simulation in 3D. Okay, so it's still loading the background because that's why the black background is blue. These backgrounds is a three-dimensional map. And why am I black right now? Because it should, this launch site, oh, there it goes. It's like the rocket is underground. Find my home. Yeah, see, I'm underground. If you're seeing black, you're underground. And I don't know why that happened. Well, the rocket's taking off and it's going to stay underground. It's not going very high underground. Let me close that out. See what happened. I got to see where my launch site is. Let me choose a different launch site that's above ground. Come on. Okay, let's choose this one here. There's a database of launch sites. I'm waiting for this to load here. Okay, so now we're getting a three-dimensional map. And my rocket should be right there. And let's see, let's launch it from there. Yeah, it's still showing it underground. If it's black, something's not right. You can see the rocket's taking off. There it goes. It broke the ground right there. Let me pause it here just a second so I can kind of give you an overview of what we got going on. So I'm zooming out to kind of get the lay of the land. Down here in the bottom corner is a close-up view of the rocket. Okay, so I was launching from right here in this grove of trees. Not a good place to launch from. You can see here, this green line is the trajectory, and the rocket right now is at that point in the flight. I'm only 4 seconds into the flight. It's already 633 feet high in the air. So that is what the launch visualizer is. And the question was, is the price of the launch visualizer going to be the same fee as RockSim Pro? RockSim Pro currently is $30 a month. The launch visualizer, I'm going to just announce this right now. The price is $3, $3 a month. And that's our introductory offer. Well, and it's kind of seeing, you know, will people try it out at $3 a month? I think it's a screaming deal. But currently, right now, we're still in beta, so we're not taking any money. So you can use it for free right now, but you can't. The limitation on the beta is it stops the simulation at apogee. And if you want your simulations to come back down to the ground and see where your rocket's going to land, like on this one right here, if I drag the slider bar, come on, go all the way to the end. Okay, so see the rocket's back underground here, and that's why you got this black background, because underground there's no light. But you can kind of see where it hit the ground right there. which is very useful information, particularly on your launch site, you know, because where you're launching from, you also have trees and ponds and rivers and whatever. You know, there's a lot of obstacles, and you want to make sure your rocket's going to land in that nice open grassy area. This one did actually launch pretty good. So again, I took off right here. The rocket went up on that green line. It hit apogee at that point right there, and then it descended back down to the ground right there. So when we actually go live with this, it's going to be $3 a month, and that will, you know, do everything you can see here, and it gives you all access to all the features. In the demo version, like I said, it will stop at apogee, and the other things is some of these starting states you won't be able to adjust. You'll be able to adjust the launch angle from vertical, which is this right here, and this angles the rocket. You can see over here, I angled it pretty far to the, you know, almost to the ground. You can angle it, you can spin it around to a different compass direction. You can actually spin it on the launch rod. This is really useful if you got a design that has wings on it, because how you launch a rocket with wings on it with respect to the wind is going to make a big difference. So that is what the launch visualizer is. So that answers that first question. Okay, so then the next one was, how do I add my own motor, my own rocket motor? And then I also have a question from Mark Sell, who sent one by email. He wants to know about coefficient of drag. And then we have Nick that asks, if I design a nose cone in RoxIm Pro and I want to send it to a 3D printer, how do I do that? Okay, that's an easy one. Shane S. from Colorado. See, I'm getting an error now that says YouTube is not receiving enough video to maintain smooth streaming. Hopefully it's coming through, because that I can't take care of. I'm going to go plug in my Ethernet cord, see if it's popped out. Yeah, I'm on Ethernet, so inside the building, I have no data now. So I'm going to forge ahead, and when we post this video, I'll post what I'm recording on my laptop, so you will have that video instead of what YouTube is getting. And hopefully that will be better quality. So first question was from Mark Sell, because he's did it first. Let me bring that up. Okay, so he says, if I understand this correct, I would conclude that the CD in the vacuum in space would be very near zero. In Roxim, it states that it calculates CD at the time of launch unless you check the box that says use the values below. Roxim has a value of 0.75 for the CD in those boxes in most cases. When I run a simulation on a design, I get a set of results and then rerun the same simulation with the box checked to use the values below. I get a much different result. In my experience, I usually get about 85% of the altitude that Roxim predicts, and that you said I could dial in the CD by adjusting that number until I get a simulation that came close to the altitude I measured. I recently tried the technique and came up with a CD of 0.35 for the PML AGM 256 Pit Bull. That model has good sized fins as well as strakes, so my gut tells me that a CD of 0.35 is too low. I am guessing that I may have gotten a false altitude reading from my altimeter initially. Any discussion on this would be greatly appreciated. Okay. So CD, let's go to Roxim. Okay, so Roxim, let's open up a design. And come on. I'll just open up the SSDIR Big Red Max. Okay, so here's the rocket. This is what it looks like in 3D. See, it's a single motor rocket. Okay, so he's talking about the CD override right here. And it says, there's a checkbox that says calculate CD at simulation time and uncheck to use the values below. So right now, these values that you see right here are being ignored because this is checked. And if you want to use those values, you'd have to uncheck it. So let's run a simulation first. I was seeing if there was any saved already. So I'm going to run a simulation and choose an engine, and I'm just going to grab one. It doesn't matter. Okay, so I got an F26 FJ, which stands for fast black jack, so it's going to produce a lot of black smoke. And it's got an ejection delay of 9 seconds. It's going to deploy the parachute at maximum ejection delay, and I don't really care. I just want to get that peak altitude. I just want to make sure it hits the peak altitude. I'll launch it on a 60-inch launch rod, straight up, with a wind of 8 miles per hour. And I click launch. And it runs the simulation, and it gives us an altitude of 1,431 feet right here. Okay, so now you go out and you put an altimeter in your rocket, and say your altimeter reads 1,300 feet. Okay, so now we need to make our simulations match. We need to match that actual coefficient of drag. But the coefficient of drag used here is not a static coefficient of drag number. And you can see that when you go up here to rocket, go to the rocket menu, and then scroll down to CD analysis. And if you do that, you get a velocity versus CD curve. So the higher the velocity, the coefficient of drag changes. So now we're interested in the red line right here, and that's the overall CD. You can see it jumps up real quick as soon as the rocket starts moving. It jumps up to about 0.4. Then it comes down until it starts getting into the compressible flow area near Mach 1. And at Mach 1, it jumps way up here. And then as it goes past Mach 1, it starts coming down again. And Mach 2, it just starts trailing out. And finally, you get numbers out there that I wouldn't trust anyway. But for subsonic, it gets you in the ballpark. And it can always be better. And this is the limitation of RockSim, is it's not a CD prediction program. It's a trajectory prediction program. But you need a CD value to get a trajectory. So it gives you some numbers, and to make it more accurate, you need to start tweaking it. So, so what value is it using right now? When it ran that first simulation, it's using this. It depends on the Mach number. So if a velocity, let me change this over here to miles per hour. If I'm at 475 miles per hour, I'm going to get a CD value of 0.318 right there. Now, but what we're saying is that we're not getting an altitude that matches our measured altimeter altitude. So we need to adjust the CD. Okay, so that's this value right here. So I'm going to uncheck the box right there, so it's unchecked right now. And then I'm going to run a simulation all over again before I even tweak it. So I'm just going to hit launch. And it just runs the simulation, and it gives me a new maximum altitude of 931 feet. And that's with now this one, I know the CD, it's a fixed number. No matter what the speed of the rocket is, it's a fixed at 0.75. And I can see that if I go to the plot menu right up here. And I'm going to make a graph, and I'm going to plot velocity versus CD and plot that, and I should get a straight line of 0.75 right there. All this stuff over here, this bouncy stuff, is after the rocket has reached peak altitude. So I can go back to preferences, and I'm going to say when the rocket reaches apogee. So if I plot it again, I should get rid of some of those values. So again, all this wavy stuff is the other thing. If the rocket was perfectly straight and there was no wind, you would get a straight line. But because we have wind, what's happening is the rocket is weathercocking, and it's wobbling back and forth. And as it wobbles back and forth, it's changing the surface area that it's exposed to the air. Because if you're at an angle of attack, the air hitting it is at on the side of the rocket rather than at the tip of the rocket. And that's why you get this wobble. So the wobble is happening right as the rocket takes off. But once it stabilizes and going straight, then I get this nice straight line because it's a constant coefficient of drag. So that's the other thing that's going on, is not only does the coefficient of drag change with velocity, it also changes with angle of attack. So there's a lot of dynamics going on there. So if you want to run, I'm going to run the simulation again. This time I'm going to turn off the wind. So I'm going to go to the launch conditions. And here under custom speed wind, under wind conditions, I'm going to change that to no wind. I'm going to launch it again. Okay, and the altitude went a little bit higher. And that's because when it was windy, it actually weathercocked into the wind. And it didn't go as high as it could have because the wind was making it go more horizontal than up. So that's why that number changed. And if I plot that CD versus velocity again, I should get a nice straight line all the way across, which is what you see there. Okay, so now we want to get to 1,300 feet. So now I need to go to my coefficient of drag and start bringing that number down. Because the lower the number, the higher the rocket's going to go. So if I go 0.35 and then run the simulation again, we'll get a new value, 1,463 feet. So now my CD is too low, so it's going to be higher than 0.35. So maybe I'll make it 0.4 and run the simulation. So now I'm at 1362, so I'm still a little bit too high. And if I bring it like 0.41, oops, let me just launch, run the simulation. 1344, so having a CD of this one was 0.4, this one was 0.41. You can kind of get the idea of what you got to do. You got to just keep tweaking it, keep adjusting this number until you get to that value you want. Okay, so I'm really close. I'm 6 feet away. Okay, so now what do you do with that value once you get it? So the value of having that coefficient of drag number is if you change the weather conditions or if you change motors and then you put an altimeter in it, hopefully that altimeter value actually measured should be a lot closer to what is predicted, because now you're dialed in on that coefficient of drag. So the other thing he mentioned in his question was, does the coefficient of drag get lower as the rocket goes higher and zero in space? And the answer to that one is no. The coefficient drag number doesn't change. What happens is the drag goes down, but that's because the air density goes down. So air density in space, there is no density because it's a vacuum. So the formula for coefficient of drag is coefficient of or drag, which is a force, equals 1/2 rho, which rho is the density of the air, times the CD value times velocity squared times an area. You know, and that area we said before was, you know, looking down on the front of the rocket, and this, you know, that circle, that's the area that RockSim uses. But if the rocket goes sideways, now you got a bigger area. So that's why you want your rocket to go straight when you're measuring coefficient of, you know, if you're trying to dial in, make sure your rocket is going absolutely straight. No wind, no wiggle, because that's going to throw it off. But the coefficient of drag doesn't change as the rocket goes higher. It changes as a function of speed, and it changes as a function of angle of attack, and it changes as a function of the shape of the rocket. So those are the ingredients that go into the coefficient of drag. The coefficient of drag and the coefficient of lift are kind of, we call them like fudge numbers, because you can actually measure the force. You can measure drag and you can measure lift, and you know the velocity, you know the density, but it doesn't quite match up, so you need this fudge factor, and that's the coefficient of drag. It takes into account all those things that are really hard to measure, and that's why figuring out an exact coefficient of drag is so hard to do. The best way right now is actually to go out and measure it. You can do it in a wind tunnel, and you know, the newest technique is computational fluid dynamics, but RockSim is not a CFD program, so you got to take that into account. And RockSim Pro is not a CFD program either, nor is the launch visualizer. The CD value is always the weak link in the software. So hopefully, Mark, that answered your question. I need to go on to some other questions. Okay, we need to go, how do I add my own rocket motor? Okay, so there's two things you got to do when you add your own rocket motor. The first one is you got to create a engine file, and then the second thing you got to do is you got to get that engine file into RockSim. So RockSim comes, if it's a motor that's already made by somebody else, typically there's already an engine file made, and there's a website called ThrustCurve. Oops, I got to spell it right. ThrustCurveorg. And click on that. Come on, wakey wakey. It's like my web browser's not doing anything. Let's open up a different web browser. Yeah, my internet is like being really slow today. Okay, so here's ThrustCurve.org, and remember we looked at that F26 motor that was already made. Here's the F26FJ. You click on it. This is all the manufacturer information, but then if you, where is it? Okay, so here is the RockSim format or the RAS format. RockSim can open either format. The RockSim format stores additional information that the RAS format doesn't. So I prefer the RockSim format, but the RAS format will work just fine. RAS format ends in .eng. My phone is going off. Let me turn that off. And the RockSim format ends in, it'll be the file name .rse. So you can download those by clicking on that. I think it added the file to my outbox. and then you can download one file. And so then it threw it into my downloads folder here. Let me open that downloads folder. Open downloads. And here's the ThrustCurve.rsc. That's the file I just downloaded. And if I open it, what's opening it? It's opening up a program called EngEdit. And EngEdit, and this is an old version of EngEdit, but it hasn't changed much. This is what EngEdit looks like. And this is bundled, EngEdit is bundled with RockSim. So if you go I'm opening up another browser window, and I want to go to my applications folder. And so here is RockSim. And there's a program here called EngEdit. And this will be in the same folder where RockSim is stored. So this is the new logo of EngEdit. The one that I had previously was the old version. So this is the old one. Let me get rid of that. And so now this is what it looks like. And if I open that engine file, I'm going to do open, and I'm going to find that file, which is in my downloads folder. Downloads folder, downloads right here. And I would like access to download. Okay, allow. Okay, so that's, I'd say open to that. And it opened up the thrust curve of the F-26. So all of these, if it's a motor that's already pre-made, there's likely to have an engine file. If you're making your own rocket motors, then you have to do it manually yourself. And what you're going to need is a thrust curve of the rocket motor. Like here, let me go back. Okay, so this is what a thrust curve looks like. It's a plot of thrust on one side and seconds on the other axis. And you'll get this by mounting your rocket in a thrust stand and downloading the data. And then from that, you need to take that graph and put it into EngEdit right here. So let me start with a brand new engine. So I'm going to delete the selected engine, and it's probably going to say, do you want to delete it? And I'm going to say yes. Okay, so then to start a new engine, you have to click this button right here. You can't start a new engine down here. You have to start it right here. This confuses a lot of people. So I add a new engine, and it's going to ask you what the burn time is and the peak thrust. So from your graph, you need to find the maximum thrust, and this one is going to be about 40 newtons, and then the burn time is 2.6 seconds. So I'm going to put 2.6 seconds here, peak thrust 40 newtons here, and you can change your units in case you're using pounds, but this one's in newtons, so I'm going to click OK. And what it does is it creates this graph right here where we can now start plotting points. So you would take this right here and move those points to here. So you can just start clicking on the graph. You can see you put the last point at 2.6 seconds, and then you can click and drag on each point to move it around on the thrust curve. Okay, so I was trying to match that. So now if you actually know the points, you can actually come in and under View, look at time ordered data up here at the top. And this will give you a chart of the time in seconds and thrust. So if you wanted to tweak a point, see, like I just clicked on that point right there, which is this point right here, and I can tell because it highlighted it. And if I click on the first one, it should be over here. Wait a minute, am I going backwards? No, that's right. No, it's not clicking, it's not highlighting them, but I can change them. I should be able to change it. Double click on it and make it like 40.6, hit tab. And did it move? I'm not sure if it moved. But you get the point. You can move your points around two ways. You can either drag them around, or you can put in the thrust curve right here. And then you need to put in some information about the motor. Like this will be, let's call it Tim motor. An engine code. This one has a total impulse of 59.9 Newton seconds, which is an F motor. So I'll call it an F, and the average thrust is 23 Newton seconds, which you get over here. So I'll call it an F23, and I'm just going to put, you know, a random letter on here, I, just so I can tell it apart. And you can say it's single use, reloadable. I'll just say single use. Ejection delays. This is in seconds, so you can have a 0 second, which is like a booster motor. You can have a 7 second. You separate them by commas, 7, 9, and then you can also have a P for plugged. Then you set the diameter. We'll say this is a 29 millimeter. Set the length. I don't know what this is going to be. We'll call it 90 millimeters. Then you need an initial mass. I don't know what the initial mass is here. Burn time, propellant weight, total weight. And so that would be your initial mass, total weight, 101 grams. Okay, so I got the spinny ball of death. What's going on? I didn't like it when I switched over. I got, like I said, everything is running really slow today. Spinny ball of death is never any good. So what is not? EngEdit is now not responding. So I'm going to force quit it. Okay, so I have this other EngEdit open here. Let me open a motor. Open. Come on. Okay, so okay, I just want to give you an example. So say you entered all this motor data, and I'm going to call it something new. I'm going to call it Tim VM motor, and I'm going to change the name. This one's an F64. Is it an F60? Yes, 64. And then you have to save it. So I'm going to do a save as, and then you got to know where you're putting it. And on my computer, I'm going to throw it on the desktop. And you have a choice. I'm going to allow that. You have a choice of RASP or .eng, or RASP is .eng, or the RoxIm.rse. And then hit save, and it will save it to your desktop. Okay, so that just is a message saying that there's a difference between RASP and the RoxIm format. So click OK. So now we have saved the motor file, and next we need to load that into RoxIm. So now in RoxIm, I'll go to Import Engine Files, and wait for it to come up. And now it's wondering where my engine file is, and I saved it to the desktop. So I'm going to go to the desktop, find the engine. Oh man, it's got .rse.eng on it. Before I do that, let's just make it an ENG file. I need my browser window back. Okay, so you see where it says .eng, .rse.eng. I only need one or two. I don't want that. I only needed the .eng part. So it's an F70. It should be an F26 or 23. .eng. Okay. And now when I go back to RoxIm, go to File, Import Engine Files. Go back to my desktop. There's my file, now named correctly. Click open, and it copied the engine into the RockSim database. So the engine is still, the original file is still on my desktop, but it also made a copy and it put it into this data folder right here. Application support, Apogee components, RockSim_1/data. And it's calling it f23.eng. So that's what that message means. I'll click OK. And now it's bringing up my current RockSim database. So here's the new file. It's not imported yet. To be used in RockSim, it has to be on the right column. So I need to highlight it and then click Add. And so it added it over to this side, and then when I click OK, it loads it into the database. So now the motor is ready to be used. So now when I go to load a motor, and I go to choose engine, I should see my new, under manufacturer name, let me sort this by manufacturer name, so it's Sky River. Okay, where are you? F22, should be an F23, but I gave it a different manufacturer's name. Let me try that again. Cancel that. Did I, when I created that engine file? I'm going back to EngEdit. The thing that I want to check is to make sure that I got the diameter right. So I'll open. And I'm just checking here. I'm not changing anything. Make sure I got it. So TBM motor, engine code, F24 millimeter diameter. So I was looking in 29s, should have been looking in 24s. So going back to RockSim, prepare for launch, choose an engine. Okay, so see before, I want to go show all that match or are smaller. Okay, so now we're showing all motors under 29 millimeters. So now when I go sort this, if I scroll down, there it is. Tim Van Milligan motor, F64. What did I call that motor? I swear I called it F23. Nope, I did call it an F64. So, if I wanted to run the simulation, I could, now I could select my delays, click OK, and then launch it. So, that was very convoluted, but you got the gist of how to create a motor and then load it into RockSim. It's not an easy process, and I apologize for that, and I think there's a bug in EngEdit. So I'll probably have egg on my face again. Okay, so Nick Verini says, I designed a nose cone on RockSim Pro and I want to send it to a 3D printer. How do I do that? Okay, so we can take this example here. So say you designed this rocket and you designed a nose cone in RockSim. So I'm going to design components, going to the nose cone. Okay, so I opened it up. You can change the length of the nose cone, so I'm going to make it shorter. So now it's a brand new nose cone, and I'm going to click on the button that says Export Template. And let's see if this is the right button. Yes. So see right here, you can say what format you want it to go in. SVG is a two-dimensional format. It's kind of like the image of the rocket on the screen. It's just a drawing. You want the three-dimensional format, which is STL. So you can save it as an STL, and I'm going to throw that on the desktop and then hit save. And now it's asking you here on this is what resolution you want your STL file in. Do you want it to be low resolution or high resolution? And there'll be a difference, and you'll notice it. I'm going to say medium for right now, and I'll explain what the difference is. So I'm going to click OK, and it exported it, and it put it on the desktop, so everything is good. Now I need to go to my desktop. Okay, and so here it is on my desktop, bid max nosecone.stl, and my phone is going off again. Thought I put it on silent. So on the Mac, I have this preview window right here, and it allows me to preview what the STL file looks like. And so that's what, if you design your own nose cone in Roxim and you export it out as an STL, that's what it looks at. Now you can see it looks very faceted because we chose a medium resolution. If we go back here and we export it again, I got to give it a different name. And we need to put it on the desktop. Let's call it nose cone number 2. Hit save, and it's going to ask me, it didn't ask me that time, if I wanted high resolution or medium resolution. But normally, you're going to want high resolution. Trust me on this, because when you go high resolution, those facets that you see will all disappear, and it'll be nice and smooth. And that's when you print it out, that's what you want anyway. So from here, you would send it to your slicer program, whatever slicer you're using, and then just print it out. The downside of this is it's going to be a flat bottom without a, like on most nose cones, you got a parachute loop on the bottom where you can attach your shock cord. When you do this in Roxim, it's going to be a flat bottom. So what you'll have to do is to put a screw eye into the bottom of your nose cone to attach your shock cord, or somehow otherwise redesign the base of your nose cone, and that's pretty hard to do too. So that was an easy question. Okay, it's nice. Advanced, good night. I'm looking at my monitor over here, just seeing if there's any other questions. We're like really close to the end of this episode. Joe Doe says, I keep calling him Joe. John Doe says, I fly out of a smaller launch site, so getting a splash pattern to avoid those trees is important to me. And that's why you would need either RockSim Pro or the Launch Visualizer. They do the same thing. The Launch Visualizer, like I said, is going to be $3 a month, where RockSim Pro is $30 a month. But with RockSim Pro, you have the ability to actually modify your designs. In the Launch Visualizer, you also need RockSim to change and modify your designs, but you can then export it and get your simulations in 3D. Marcel says, thanks for the discussion on CD. It helped a lot. Karen Ma says, building a rocket that will deploy 3 flaps as air brakes at a preset altitude. Is it possible to cheat Roxim to run a simulation of a rocket like that from 0 to 800 feet with one design and no flaps? So she wants to run air brakes. And I think I kind of thought about this a lot. And I haven't found a way to deploy air brakes in Roxim other than using a parachute to simulate the air brakes. So that would be how I would try to do it. So how would you do that? So you would set that up as dual deployment in a rocket. So you need a separate parachute in here. So let me cancel out of that. Save my changes. No. Okay, so here's the original rocket. And I'm going to add a second parachute, which will simulate the air brakes. So I need to add a parachute. You can either use a parachute or a streamer. So I added a streamer, And I'm going to choose a 2-inch wide streamer, and it's right there right now. I'm just looking at it. I'm going to change the location, move it back a little bit. It's not really going to affect the flight going up at all because the mass of that parachute is so low. So drag brakes would be something on the bottom of the fin or something that increases the surface area of the rocket so that it slows down really quick. And a parachute does that. But we want the parachute to deploy on the way up. So we have a streamer in there. So now I would go to flight prep. Let me choose a different motor other than the motor that I added. Let's choose I want something bigger than that, but not an H size. Let's something an E or an F. So let's choose this one. And I'm going to say custom. And I'll say 2 seconds. So this one will deploy, I'll just use it. Okay, so I have a 2 seconds, and then I got to go to my flight events, and I have 2 events. I have a parachute event and a streamer event. And under streamer, I can deploy it at an altitude. Ooh, I can deploy it, but this altitude is on the way down, not on the way up. In RockSim Pro, that would be on the way up, but in RockSim, it's on the way down. I can do a time after ignition. That would be good. Okay, so I'm going to do 3 seconds. Let's call it 2 seconds after motor ignition. But let's see, this motor, I need to know how long this motor burns. This motor burns for 2 seconds. So having it 2 seconds after ignition would be like a 0-second delay. So I am going to say, let's call it 4 seconds after ignition. So as it's going up and coasting, so this time it's measured from liftoff. It's not measured from burnout. It's measured from liftoff. The streamer should pop out. And then my parachute, I'm going to say deploy at apogee. And then go to the flight profile to see what that looks like. Let's see if this is working. It's loading the sprite files. Okay, so here's my rocket down here in the corner. I'm going to make this screen a little bit smaller. So there's the rocket. Let's click launch. It's taking off. 1,000. So 4 seconds. The streamer should have popped out. The streamer did not pop out. There's my streamer. It deployed the streamer at apogee. That's not right. Did I set it up right? So we'll go back here to flight events. Streamer at deploy at time after ignition, and my parachute at apogee. I should have saw the parachute come out at apogee. Let's cancel this. Let's save this to the desktop, and I'm going to import this into the launch visualizer, because the launch visualizer, I think we can do something crazy. Der big rocket, and throw it on my desktop. .rkt, hit save. Okay, so it saved it onto my desktop. So I'm going to go back to the launch visualizer. So here's the launch visualizer. That's not right. I want to be in the Chrome version. New window. Roxim. It's loading it. Okay. It's not finished loading yet. It has to go through this. Okay, let me see if I am logged in. I am still logged in. I'm a premium member, which should be good. So actually, I didn't want to. I need to upload a new rocket design. So I'll come here, click on Upload, and I'm going to browse on my desktop to find that button or that rocket. So I've got to go to my desktop, Der Big Red Rocket, click Open, and I'm going to upload it. So now it's taking it from my desktop, and it failed to upload. Why did it fail to upload? Open and upload. Please don't fail this time. And it failed to upload. Okay, we'll select the design from the database. Let's see if I got one that has dual deployment in it. I don't think I have anything. Oh, here we go. Katana. Select. Katana has 2 parachutes. It's a dual deployment rocket. So what I want to do is to deploy 1 parachute on the way up. And what that's going to do is it's going to really slow down the rocket. And then I want to deploy the other one at apogee. So let's go to load motors first, because we need a motor. Select motor, come on, wake up. Choose an engine. Man, it's lagging. It's like I've got so much going on my desktop that it's being really slow. Because normally this is pretty fast. Okay, so it should only be showing engines that match the motor mount diameter. Okay, I'm just going to select one here. Click OK. So now it loaded the motor into the rocket. Now I'll go to my flight events. Okay, so here's the drogue chute. So this is going to be our simulated drag brakes. And I want to deploy this one at a time after ignition. Again, we said that was going to be, well, we changed motors now. Let's call it 6 seconds after ignition, and then the main parachute will deploy at apogee. And let's launch this and see what happens. And simulate. This is, Karen, this is the only way that I can think of deploying drag brakes on a rocket, is you got to do it as a parachute or a streamer. And then the question is, how big of a parachute or how big of a streamer do you need to simulate the rocket slowing down really fast? And the answer to that is in the coefficient of drag again. You need to know when you deploy your drag brakes, what is the coefficient of drag of the rocket at that configuration? And then your streamer or parachute would probably be better to use because the area is easier to control. And then you would set the area to the area of your rocket with the drag brakes deployed, and then the coefficient of drag that you found somehow by experiment of what that coefficient of drag is. So again, we're underground here. We're going to launch anyway. Rocket's coming up out of the ground. Why is it underground? It's still underground because it's all black. Now we're above ground. Okay, so we're at 4 seconds, 6 seconds. Okay, something happened there. It slowed down really fast. Let me stop the simulation, and I want to back out. I'm zooming out here so that I can see the trajectory of the rocket. And I'm going to change to a trajectory view. We're going long here again. Long is in time. So that's the trajectory of the rocket. Boy, oh boy, it launched from way out there. Now I want to zoom back in and see what's going on with the rocket itself. Actually, I can just hit the rocket, find the rocket button right here, and it will center the rocket right in the middle of the screen. And then I can zoom in. I should be able to see what's going on. And I'm seeing a very, very tiny parachute right here that's deployed. Okay, so now I'm zooming in too far. Come on, zoom back out. Find the rocket. I lost it again, so I'll just click on that button. Zoom, okay. Okay, so here's the trajectory of the rocket. Now we want to see if that parachute is open as the rocket is moving upwards. So I'm going to take the time scrubber and move it backwards in time. Find the rocket. So at this point, it's still in. The parachute is not deployed. Let me zoom out a little bit more. Because if the parachute is out, you'll see it right above the rocket. Okay, so now I need to scrub here through the time slider. Okay, so here's the parachute. It came out, and the rocket is still going upwards. So watch this number right here, altitude, and if that number goes higher, the rocket is still moving upwards at a different time. So I moved it higher, and it did go higher. So actually, the drag brakes have deployed, and the rocket is still moving upward because it still has a lot of velocity, and it's got to burn off all that upward velocity before it slows down enough to hit apogee, and at apogee we have the main parachute popping out. So it's getting to apogee. You'll see the green dot at apogee right there, and then the parachute changed to a different parachute, to the bigger parachute. So Karen, that's all I got for how to deploy drag brakes. Fatbank asks, any updates required for Windows 11? Yeah, going from Windows 10 to 11, you do need to upgrade. Does Roxim work under Windows 11? That is a good question because we don't have Windows 11 here, so we haven't tested it on Windows 11. I would use caution because every time Microsoft creates an update, it breaks Roxim, which is why we are going to the launch visualizer as our future. Because Windows and Macintosh, they keep breaking it. Shane says, did my question not pop up? He asks, I am upscaling your Javelin design and wondering if Roxim has the paint scheme in it. That's a good question. I don't know. Apogee doesn't make a Javelin, so it must be some other manufacturer. And so if you, we can look. Javelin, and there is no product suggestions for Javelin, so we don't even sell that kit, so it's on another manufacturer's website. So what the question is, does it have the paint scheme on it, like this one right here? My guess is no. And I say that because most people don't color their rockets in RockSim because they don't know how important that is. It's important because when you go into the launch visualizer, the rocket is colored and it's so much nicer to watch. Okay, so we are way past time again. So I really need to stop. So here I am, and my screen is frozen, and I apologize for that. We will put up the replay that I have saved on my computer as the one on YouTube so that you can watch it, and hopefully everything will sync up a lot better. So thanks for watching. Thanks for putting up with our technical difficulties. We always have these. Technology doesn't quite work the way we want it always. So we'll be back again next week, same time, which is 2 p.m. Mountain Time, which is 4 p.m. on the East Coast. And I don't know what time that is in the rest of the world, but I'm sure you can figure it out. I think if you subscribe to our YouTube channel, you will get an update when we go live. So that will just like pop up automatically, say, hey, Apogee is live. So check your email. Make sure you subscribe to this channel. And it would also, I'd appreciate it if you like it as well. That helps us get more viewers because the YouTube's algorithm sees that like, and it says, hey, other people might want to watch this too, so that we get more viewers. But the most important viewer is you. So thank you for watching. And we'll see you next week. And I'm going to end the stream in 5, 4, 3, 2, 1. End the stream.